start by introducing the subject. Today we'll be talking about machine lubrication and the management of it to save companies and reliability engineers some money as far as cost is concerned. So I'll take you through the history of lubrication. In the Middle Ages, we had very simple machines, as you see on my slide, and this required some amount of lubrication. And back in the day, they used water to lubricate these wheels, and water over time got the hubs bent out, and it wasn't as efficient as they were being a lubrication was expected to be done. Then we moved the dawn of industrialization and the recovery of hydrocarbons, oils. We moved into mineral. We moved into the use of mineral oils as lubricants. Then in the mid 20th century, we moved into synthetics, and a lot of work is still ongoing as far as synthetics are concerned. So it's been quite a journey as far as lubrication is concerned. Going forward, the plan is to extend drain intervals and also come out with technology that tends to save the environment. And there we'll be talking about environmental compatible lubricants. So, to start with my topic, because you have a lot of upstream players listening, um, I need to I need to do the connection. So, with upstream operations, drilling and production, of course, they work with machines, and lubrication is very important as far as their operations are concerned. And in there, you'd see engines, transmission, turbines, cutting tools, hydraulics, all kinds of machines are there and have been employed to drill and to also produce. And you cannot undertake these operations without lubricating. When we talk about lubrication, it is not just about reducing friction. Of course, that is the primary objective of lubrication. But there are other things like evacuation. There are other things like power transmission that are secondary functions of lubrication. And if lubrication is not properly done, then your maintenance cost shoots up, your downtime increases, you have issues with equipment availability. Then when you have wrong products being applied, then there are some safety issues that you'd have to deal with. In terms of the efficiency of your machines, you are not going to get anything close to 80 to 90% as far as the machines efficiencies are concerned. Then your equipment do not last. They do not serve their shelf life. All these things add to the cost of operation. If you look at my slide, you see that the cost of lubrication or lubricants in any operating plant is about 15% of the total cost. And if you want to delve deeper into this 15%, you have about 45% of that being incorrect lubrication and incorrect assembly or misalignment. Then there are other factors that also lead to high maintenance costs. Maintenance cost is about 30%, but in there you have lubrication contributing to about 15%. So trying to cut down on cost, you cannot do without focusing on lubrication and employing on the right techniques and modern methods of lubricating. So in my presentation, I'll be focusing on cost-cutting approach. And the first subject I would want to touch on is on product specification. When we talk about product specification, a lot of maintenance and reliability engineers have reduced specification into viscosity. Of course, viscosity defines the film thickness of the area to be lubricated and also gives you a fair idea of the load bearing capacity of the oil. But that is not enough. Specification is not only on viscosity. Specification is also based on performance. Lubricants are categorized based on their performance level, and it is important that maintenance engineers and reliability practitioners get to understand the difference between viscosity and performance levels of lubricants. For different applications, we have different specifications. When we take an engine oil, the performance ratings are in these stated specifications. You have the API, which is the American Petroleum Institute. We have the Asia specification. We have the Japanese specification, that is the JASU. We have the European specification, which is a combination of the API and the ASIA, which we call the ILSAC. These specifications are very important as far as lubrication is concerned. An equipment may require a 15W40 or an ISO 68 specification in terms of viscosity. But if you don't understand the performance rating of the oil, then you are likely to put the equipment or the asset in danger. Machines are designed with lubrication specifications. If you take a common engine oil, the engine may require specification about, let's say, 15W40, a 20W40, a 5W40. That only describes the fluidity of the oil. But in terms of the performance, there are different categories of performance. And I would want to state the API examples. So if you take a simple vehicle engine, most performance ratings, as far as the API performance ratings are concerned, we have the SN, we have the SP, we have the SF, and we have the SL. So the SP is the modern specification, which gives you optimizes 90% lubrication. Then we have the SM plus, we have the SN. They all come below the SP. As you move from SA to SB through SF to SP, then the oil is becoming better in terms of its ability to lubricate, in terms of its ability to handle wear, in terms of its ability to cool, in terms of its ability to handle wear deposit, and even to handle suspended particles in the engine. So you cannot take specification for granted. So SASB up to SP, that is what you are likely to get for your normal petrol engines. So if your vehicle specifies a 5W40 or a 10W40 or a 15W40, that 15W40 is not enough. You need to know the performance rating of the engine oil. And here I've stated the S series. Oil that are specified to be used in SB, oil that have SB specifications. These oils were designed for 1930 engine technology. So your vehicle comes with a 15W40 specification. Now, the next thing you have to look out for is the performance rating, as far as American Petroleum Institute is concerned. So if the performance rating is an SP, which is a 2015 engine technology specification, then you have no business going as low as SB. SB is 1930 technology. And those of us who are in engines and machine design, you have a fair idea the kind of technology that birthed a 1930 engine. Clearly, it will be a 15W40, but if you buy an SB 15W40, then you are putting your equipment or your engine in danger. And the same applies to all kinds of machines, be it turbines, be it gears, be it compressors. They all have specifications. They all have specifications. And the specification decision should go beyond the viscosity, and the focus should be more on the specification, be it ISO specification, be it OEM specifications. And we have some specifications that they are not international standard specifications. For that of API, ILSAC, ASIA, and JASO, these are industry standard specifications. We have OEM specifications where you have John Deere coming up with their own specification. You have Siemens or Flender coming up with their own specification. So the conversation on specifications should just not be based on viscosity, but also the focus should also be on the specification. The two work hand in hand. You get the viscosity right and you get the specification wrong, then you are not doing proper lubrication. And these are areas where maintenance and reliability practitioners must focus on, try so to save the company some money. And equipment that is supposed to run on an SP specification, using engines as example in this instance, would do longer drain intervals than going in for an SF or an SD or an SD specification. So it makes the specification conversation very, very, very important and very, very, very crucial in reliability and asset management. The second point I would want to touch on has to do with operating conditions. For the specifications, they always come with a manual. They always come with a manual. So what you do is you go to a reputable oil marketing company like Shell, then you share the specification. They go into their portfolio and assist you with the right specification. Operating conditions. Operating conditions usually are determined by the nature of the environment and the type of equipment and even the running hours of the machines. In lubricating, it is very important to look at the operating conditions of the equipment. You may have a manual specifying a certain specification, but the very moment you move the specification out of a certain environment, then the operating conditions change. And in instances like that, you would need to tweak the specification to meet the operating conditions. When I talk about operating conditions, what do I mean? I mean machines that undergo frequent start and stop. They are machines that operate under extreme temperatures. They operate under extreme temperatures. In here, we can have temperatures as low as -10, -9. You can have temperatures as high as 150, 200 degrees. So you cannot do lubrication without taking into consideration the operating condition. Temperatures are one of the parameters you can be looking at, heavy loads, etc. Then the environmental consideration. An equipment that is working in an industrial environment, an equipment that is running in a dusty environment may not meet the same drain interval as those that run in an environment that is dust free. So you may have the drain interval as specified by the manual to be 250 hours for heavy duty equipment engines. But because you are running a dusty environment, chances are excellent that you would have to reduce your 250 hours to 180 or 170, contrary to what the manual is saying, because of the special environment that you find yourself in. In an environment that is very saline, for our colleagues who are in upstream, clearly you cannot stay within the drain interval as stated in the manual, because you'll be taking the equipment into a special environment and you will need condition monitoring to optimize the drain interval, looking at the specification and also looking at the special environment in which you'll be operating. So in here, I've highlighted the need to look at the specification, the viscosity, and the performance ratings. Then the operating condition also of the equipment. Then environmental consideration. As you move my machine from one environment to the other, the lubrication has to be looked again. My second point has to be on oil condition monitoring. For reliability and maintenance practitioners, you need a proper lubrication program to determine when to change oils, how to change oils, and even the parameters that you are looking at. So the program will give you the right drain intervals, taking into consideration the earlier point I have raised, the specification, the operating conditions, and the environment. So if you are managing assets and you don't have a proper or a systematized lubrication program, then clearly your cost is going to go up and you're going to jeopardize your machines in no time. So with a proper lubrication program, you are looking at a set drain interval, and this is determined by the environment, the operating conditions, and the specification, i.e. viscosity and the performance rating. You'll be looking at sampling, the sampling methods, how you are sampling, then the parameter thresholds. What are you looking at? Are you measuring wear? Are you measuring contamination? Are you measuring some of the physical properties of the oil, like viscosity? You know that if viscosity is increasing over time, then clearly you are expecting some levels of contamination. You want viscosity to stay constant as far as lubrication is going on, constant plus or minus 10% of the set viscosity for lubrication. So a proper lubrication program has to be in place for maintenance practitioners to adopt as far as maintenance is concerned. And in there, you have important parameters for you to use to measure when to drain, how to drain, and even the threshold levels that you are measuring. Second point in condition monitoring, I'm looking at identifying contamination. Identifying contamination. The fact that the oil is is new or is fresh does not mean the oil is clean. The fact that the oil is coming from a new drum does not necessarily mean the oil is clean. We have contamination coming from inside the system and some coming from outside the system. Some are generated by the machine, some coming as a result of external factors like dirt, water. Then we have oxidation also generating sludge. We have issues of misalignment or viscosity degradation generating into where particles. So contamination identification is very, very important when we are looking at oil condition monitoring. Your environment will give you a fair idea the kind of contamination to expect. Your operating conditions will also give you a fair idea of the type of contamination to expect. If you are operating in very extreme temperatures, then you know that oxidation levels are likely to be high, and sludge formation and varnish formations are common in such environments. Now you look at controlling contamination. How do you control contamination? Contamination control always starts with training of maintenance practitioners. With my experience, oils most of the time are even contaminated before they are put into service, and sometimes it has to do with product storage and product handling. You have oil drums being kept in the open. There are some oils like turbine oils that you need to greases which you need to keep indoor, but because of space constraints, sometimes we are forced to keep some of these oils outdoor. And in processes in doing so, the oil sucks in air over time. This air condenses and turns into water. And when you have water in even as small as 5 or 3 ppm going into the drum, then it's likely to react with some of the additives in the oil, degrading the additive and contaminating it even way ahead of time. And what contamination does is that it reduces the drain interval of this oil. And reduction in drain interval also means cost. You may have gas engines upstream or very heavy duty engines that can take as much as 20,000 liters, some capacity of 20,000 liters. Issues of contamination means you have to throw everything away and fill the sump again, and that is cost. That is cost, and it is important that as we are controlling contamination, we train our men on product storage and handling. Then the issue of filtration also comes to the issue of filtration also comes to the fore for discussion. You need proper filtration to take away some of these contaminants. Some of these contaminants are just inherent with the operation. So you need proper filtration systems and regular change, a systemized change of filters, and not just any filters, approved filters. Talking about filters, I've been on plants and some industries where people use fuel and other diesel and hydrocarbon products to clean filters. All these practices are not good as far as contamination control is concerned. Here you have to refer to the OEM manual and the advice given by the OEM as far as the equipment is concerned. Breathers. We use breathers to control the ingress of dust and wet air. You cannot run a plant, especially a cement plant or a proper machine without breathers. You need good breathers, desiccant breathers, modern breathers with valves that can easily exit some of these wet fluids in there, and also control the entry of dust into our oil reservoirs. I've touched on training, so I won't say much on training. The other point I would touch on as far as cost control is concerned has to do with oil rationalization. Oil rationalization. Why is oil rationalization important in cost cutting? You can have assets of different types and different kinds. You can have you may, if you are in a construction firm, you may have different types of heavy duty equipment from different OEMs. You have Hitachi, Komatsu, Terex, Liebherr, different equipment, and you would need to do some rationalization as far as the engine oil use or the gear oil use is concerned. In there, you go in for the highest spec. You go in for the highest spec. And going in for the highest spec, what it means is that the highest spec can also, in lubrication, you call something reverse compatibility. If the oil specification is X and you have an oil with a high specification X plus one, in most instances, with few exceptions, you can use the X plus one on the X specification. So in doing portfolio rationalization, you look at the different types of equipment you have and how best you can optimize lubrication going in for the higher spec. The higher spec may sound expensive, so you look at the volume of equipment you have that will run on the higher spec as against the very few that will run on the lower spec. If it's the other way around, then it will not make sense to go for rationalization. Anytime you are looking at rationalization, you have to look at the numbers. You have to look at the pie. In terms of contribution, what is the percentage of the higher spec? So if you have a higher spec of about 18% or 90%, then you are better off going to doing rationalization. If you are not doing rationalization, then what it means is that now you are likely to be dealing with different suppliers for different specifications. Issues of space storage will also become a problem. If you are not doing rationalization, then there's also a high possibility of contamination and cross contamination. In doing rationalization, you have to look at the nature of your business. A business that predisposes you to huge variety of OEMs, then rationalization is important. The machine size and variation, I've spoken about it. You also have to look at your environment. In terms of lubricant portfolio, wherever you find yourself, you ask yourself, do you have you have OMC giants who can supply you with these oils? So if you have an environment where Shell is strong, Shell is massive, you know that Shell has been in the business for over 100 years. They are pioneers as far as lubrication technology is concerned. So that it is easy to do rationalization in such an environment because they have what it takes to give you the whole gamut as far as lubrication is concerned. In a smaller jurisdiction where you don't have major players in there, then rationalization will not be a cost-cutting tool. Your storage location. Areas like upstream where you may be limited with space, rationalization is very critical. And in choosing your supplier, you also have to look at a supplier that has modern lubrication technology and high spec lubricants that can speak to the issues of rationalization. Then the nature of your supply agreement. Are you doing consignment or you are doing direct sale? You can do rationalize. It's easy to do rationalization when you are running a consignment supply agreement than a direct sale. This is a new tool that OMCs use to support industry. And this is an area that you can also use to cut down on your cost as far as maintenance and lubrication cost is concerned. And this is lubrication inspections and audit. For the top OMCs like Shell, you have lubricant engineers and tribologists who have worked on heavy duty equipment, they've worked on mills, they've worked in the mines, they've worked in the power industry, who understand how these machines work. Occasionally, you invite them over to come and do a value improvement audit. And this value improvement audit, they look at all your lubrication points from the start of the process to the end of the process. And in there, they will identify a lot of abnormalities. They will identify a lot of poor practices. They may identify a lot of obsolete practices. They put together a report and help you to correct them. I have had the experience to do some of these lubrication inspections and audits, and for obvious reasons, I can't put some of the companies here, but some of them were able to save them as much as $25,000 to $70,000 a year, based on the agreed projects. So this is a modern tool that OMCs use to support industry, downstream mining, manufacturing, cement. So this is one area for maintenance and reliability engineers, so that you focus on those expertise, consultants and lubrication and tribologists who can come in there, do the audits. You can do it maybe once every 3 years, do the audit, help you close some of the gaps, and also catch up with modern technology. Some of the equipment may be old. Then we have an equipment that was put together 10, 15, 20 years ago. At the time, the top tier specification at the time may be obsolete by now. And because you are not a lubrication person or a tribologist, you may not understand or appreciate how far modern technology has moved. But when we bring in some of these experts, they are able to help you close that gaps. Recommend oils that will do longer drain intervals. And when we're talking about longer drain intervals, we are looking at savings in terms of downtime, savings in terms of hardcore maintenance work, savings in terms of possible machine damage. So this is one of the areas that maintenance and reliability engineers can employ to cut down on cost as far as maintenance is concerned. And in there, they run trials, they do trainings, thermographic and vibration analysis. These are some of the tools they use as far as the audits and the inspections are concerned. Talking about cost, I've spoken about cost, and all has to do with financial cost. My last slide will be touching on the environment, reducing carbon footprint. Lubrication technology has moved beyond synthetics. Now, what we seek to do is to put together or blend oils that are compatible with the environment, oils that are free of heavy metals, especially for those of us in the upstream business. We are now coming up with oils that will protect the environment. And even for modern day engine oils, we have oils that run on SP specifications. These SP specifications are, we call them eco-friendly. They are emission compatible, and they are designed to reduce the amount of emission that comes out from our exhaust. For industry, we are trying to limit the use of heavy metals in the blending of our oils and additives that are poisonous to our environment. We can't talk about cost without talking about the environment. We can have technology that will extend drain interval, but if it tends to pollute the environment, then as far as I am concerned, it is costlier than and saving money. So the environmental cost is also one of the areas that modern lubrication experts are looking at and trying to save the environment. Thank you.
Thank you so much, Mr. Kofi Boachi Ajimai. Thank you very much. Thank you very much. That's a very thorough presentation. On my notes, I took notes on cost cutting approach in lubrication. I also took notes on oil condition monitoring, and I also took notes on oil rationalization. The floor is now open for questions. Please, if you have any question, kindly unmute and then you ask your question. If you have any other question, you can kindly unmute and ask your questions, please. Hello, anyone willing to take the first bite? All right, I'll take the first bite then. Under oil rationalization, you made mention of machinery size and variation, right? Does that mean that we'll need a different under oil rationalization, right? You made mention of machinery size and variation as a factor, right? So I want to ask, does that mean that depending on the kind of vehicle you drive, you need a different type of oil for it? And how does it affect it from smaller vehicles to the mid-range size to the bigger ones?
Okay. So when we talk about oil rationalization, it won't be applicable to private use. So that we are looking at someone who runs a transport business and has quite a number. He has, let's say, 50 to, let's say, 70 trucks. And these 70 trucks, you'd have about 45 or 50 of them requiring a CI for oil, which is a high specification. Then the other 20 will require, let's say, a CF oil, which is a lower specification. Now, you'd have to look at the contribution to the bulk, the different sizes. The CI, you have about 80% of the CI specifications. Then you have, let's say, about 20% of the CF specification. In situations like this, you are better off going for the CI for the whole set. Reason being that if you go on the CI for the CF, you make gains in drain interval for the CF because in terms of specification, the CI is way higher than the CF. You can do the normal thing by focusing on the CI for the 80% and also doing the 20% on the CF. But there again, you'd have to buy different oils. The issue of cross contamination is there. The issue of bringing in the different OEMs at their respected drain interval also also increases your downtime. And in terms of equipment availability, you won't get that benefit. So if you put all of them on the CI, then you know that you are extending drain interval for all of them, even for the one that meets, even the one with the lower specification. Then you save money on asset availability for production. I don't know if I answered your question.
All right, you did. You did. Thank you very much. Thank you very much. Any other question from anyone else? Kindly feel free to unmute and then ask your question, please. Hello. Let me check the chat box. Okay, there is no question over there. Yeah. Please feel free to unmute and then ask your question, please. Anyone on the call? Or does that mean we are all sabbering and then we understood whatever that was presented to us? We are well within time, so please feel free to ask for anything, clarifications. He's from Vivo Energy Ghana Limited. You can even ask for free fuel, please. That's on a lighter note. Hello. Anyone on the call?
Hello, sir.
Mr. Robert, yes, please ask your question, please.
Yes, thank you very much. My question is the presenter made mention of synthetic oil or oil that protects the environment. I would like to get further clarification on that because I was happy when I heard the protection of the environment. So I would like to get further clarification on that. Thank you.
Okay.
Right.
All right. Okay. So talking about synthetic oils. As a matter of fact, when you take a drum of oil, it's made up of two things. We have the additive and the base oil. So the base oil has the natural lubricity for lubrication. What the additive does is that it improves the quality of the base oil, or it introduces an additional value. That is what the additive does. With the base oil, we have two types of base oil. We have the mineral and the synthetic. So with the mineral, we get the mineral from our crude. We do the distillation, take a fraction and additivize it, add additive to it, depending on where we are taking the oil. If we are blending the oil for, let's say, a refrigeration compressor, of course, because of the very cold environment, you put in additives that can allow the oil to still stay fluid, even in low temperatures as low as -6, -9, -12 degrees. If you are blending the oil for engine application, you know, because of the combustion effect, the engine has very high temperatures. So you additivize the oil in such a way that it can withstand extreme temperatures. It will not break down. It doesn't break down easily at rise or increase in temperature. So the additivization is done based on the environment in which you are applying the oil. Talking about the base oil, the first one is the mineral base oil, where we take crude, then we additivize it based on the application, the type of application. When it comes to synthetics, we realize that because the base is crude and it is coming from the ground, so to speak, and there are some levels of sulfur that affects how the oil behaves in service. There may be some oxygen in there. There are some chemicals that we cannot even take away with modern ways of refining and distillation. And those, they are still in the DNA of the crude, and you cannot really do much about it. So with modern technology, you can still extend the drain interval, but because of those inherent or natural contaminants in the crude, you cannot really do much. Now we go to the lab and we say, okay, if we put a normal 15W40 and subject it to thermal stress, 500, 600, 700, the oil will break down in no time. So you have a hydraulic oil, which is a mineral oil made of crude and additivized. You have a hydraulic oven, an application, a hydraulic oven. So I said you have an oven which has a hydraulic gate. And because the oven is operating at 600 to, let's say, 900 degrees Celsius, you need a hydraulic oil to operate this hydraulic gate. If you use a mineral oil, the mineral oil will burn out in those extreme temperatures. So what do? We go to the lab, we study the chemistry of the mineral oil, its limits. Then we artificially create an oil, okay, that mimics the behavior of the mineral oil. But this time, we have the room to play with the material. We have the room to play with the chemistry. We have room to extend the drain interval. We have room to allow the oil to still stay fluid even at -3 degrees. We have room to play with the design for the oil to operate even at 700 or 900 degrees, depending on the application and the environment. So we went to the lab and we were able to tweak the mineral oil, look at its features, what it can do, what it cannot do, then extend the limits. And that is what births synthetic oils. So synthetic oils are artificial oils that we create in the lab to extend the limits of the mineral oil. So in so doing, elements that naturally are poisonous to the environment, we are able to take them out in the chemistry because it's artificially created. So synthetics are better. They give you a longer drain interval in terms of their reaction with seals and materials, they are better. They give you a longer drain interval. In terms of oxidation, they are slower to oxidize. So synthetics are better. It's just that they are expensive because of what goes into their blending. Thank you.
All right. Thank you very much. Thank you very much, Mr. Kofi Boachajiman. There is a question in the chat box. Someone is saying, please, what is the best instrument to check on elements of lubrication additive?
Say that again.
I hope you got
Say
the
that
question,
again.
please.
Yeah, no, give me the question again.
Okay, someone is asking, what is the best? All right, what is the best instrument to check on elements of lubrication additive?
Okay, so in checking for additives, you need to do oil analysis, and in there we employ spectrometry to do that. Different oils have different additives. So if you look at a typical engine oil, you are looking at an additive that enhances the oil's performance to perform against wear. You have additives that help the oil to neutralize acids that come from the fuel. So in measuring these additives, you submit the oil to spectroscopy methods. It will break down the elements in the oil. Then it will tell you the additive levels. For hydraulics or for gears, you'll be looking at EP, extreme pressure additives. These additives are made with some elements. So for a typical anti-oxidation additive, you'll be looking for zinc. You'll be looking at the levels of zinc. For, let's say, for that of EP, that is additive that handle extreme pressure, you are looking at levels of phosphorus, you are looking at levels of zinc again. For you to measure the cleanness of the oil in your lab analysis, you'll be looking at calcium levels, high or how low the calcium levels are going. So with measuring the tool for measuring the additives, you have to submit the oil to oil analysis, and the report will give you everything. Yeah.
All right. Thank you very much. You also made mention of fuel. So
Yeah.
once you mention fuel, let me ask this question. Someone bought a spark plug, right? He was using it outside of the country. Once he brought the vehicle to Ghana and then he bought fuel within some few kilometers, the performance was nothing to write home about. He had to use brute force on all 8 cylinders to push the vehicle from where it stopped back to Accra, right?
Okay.
That is the effect of bad fuel on the plugs. Do we have the same effect on bad engine oils on the effective running of vehicles caused by these spark plugs?
Okay. So the engine oil may not have effect on the spark plugs, but it can have effects on the valves, on the pistons and the cylinders. So because it is lubricating and lubricating at very extreme temperatures, you need an oil that can withstand oxidation. Okay, you have an oil that can withstand oxidation. That is why the oil's ability to stabilize itself against rising temperature is very important. So we have an additive that we call the anti-oxidizing additive, which is very, very critical in engine oils. If the oil runs low on the anti-oxidizing agent, then in no time, your oil will burn out. It will turn into sludge. It will affect lubrication. It will give you issues of filtration. Then if the oil contains a lot of metals, okay, when I say metals, I mean elemental metals. These elemental metals are used to create the detergent additives. In as much as the detergent additives clean the engine, if they are in excess to it, it gives you problems. When temperatures go up, the oils burn out and these metals turn into ash. When they turn into ash, they begin to what's the word? they wear out the valve seats
The
in the engine.
wells, right?
They wear them
Right.
out. So you need an oil that will call something a TBN. So every oil, especially for engines, have a certain level of base, a certain level of basicity in there. The fuel in its operation generates a lot of sulfur, generates a lot of acid. So the lubricant for that particular engine is designed in such a way that the base number goes to neutralize the acidity of the fuel in operation. So if you don't buy the right oil as specified by the OEM in terms of viscosity and performance specification, and you buy because of price, then you may have a fuel coming in with high acidity, but because you decided to go outside the specification, you may buy an oil that has a very low base, and it may not be able to neutralize the acidity of the fuel, and this will begin to give you serious problems. So buying oils, whether it's gear, whether it's transmission, whether it's hydraulic, whether it's for compressors, whether it's for turbines, it is important to always respect the specification. Talking about fuel, we have some engines that have a certain fuel specification, and it's important to meet those fuel specifications. So if you have an engine that is set for, let's say, a 30 ppm specification, and you bring it to Ghana, and the best you are getting is a 50 ppm specification, clearly your engine will not last because you don't have that specification within the jurisdiction, and the vehicle will run into challenges. Thank you.
Right. Thank you so much. Thank you so much. Someone is also okay. He's saying, can we get a recording of today's lecture? Yes, we'll put it on our YouTube channel and everyone. Okay, I can see Richard Boache. Are you clapping or you want to ask a question?
Yeah, I want to ask a question. I just want to pass this question by.
Yes, sometimes please go on.
Okay, the question is sometimes you can go to a plant and you see that there's an old pump which has no nameplate for you to extract maybe the data sheet to know the type of oil, the right type of oil to select. So in that case, can you please assist me with maybe some of the criteria you have to consider before you can choose oil to save cost for that kind of machine?
Okay, so one of the things you'll be looking at, the key things you'll be looking at is speed. So there is a certain relationship between speed and viscosity.
Okay.
So you look at the speed, you look at the environment, you look at the temperature conditions, the range in which the pump is operating. Then you can also look at if there is a filter nearby, if it's hydraulic, it shouldn't be anything more than 20 microns. So there are things. That's why in the cost-cutting approach, I said the audit and the inspection for lubricant engineers and tribologists is very important. These are some of the areas they can easily the gap for you based on their experience working on machines and the understanding of the oils. So those are great areas, but people with experience can easily sort it out easily for you. But if I happen to be on the field, those are the things I'll be looking at. The type of pump, if it's an eating pump, I know what to do, where it is located. I have a fair idea the kind of speed. I'll look at the filtrability levels, and then I can easily advise on what to use. Yeah.
I think I'm
right. Thank you so much. Any other question before we bring the meeting to a close? Any other question? All right. On behalf of the section officers and then the board, as well as the members of the SP Ghana session, we would like to express our heartfelt appreciation to the speaker for today's presentation, Kofi Boache Agyeman of Vivo Energy. Thank you very much for your imparting of knowledge to our members. As vehicles abound around us, this presentation is very, very timely and very important, and we've taken all the notes and then we'll apply them in our daily lives. Once again, Thank you so much. Thank you so much, and we are most grateful. Some few announcements, and then we'll bring the session to a close. We are being reminded that we have 2 months to end the year, so please go on our SP website and then renew your membership. If you are finding anything difficult, please reach out to any of the executives, and then they will help you out. We also have a YP link for debaters. We have a set of debaters being trained, being groomed up for the section. So if you're a young professional and you want to be part of the debaters, please, there is a link. There is a link in our WhatsApp group. Please reach out to the YPT as well, and then join the list of the debaters. In October, on the October 17th, we have a DNI, a diversity and inclusion lecture on the title When Faith Meets Faith. So the first faith is FATE, meets FAITH, a survivor's experience with breast cancer awareness. As we all know, October is a pink month where we celebrate our women, or where we remind ourselves of breast cancer. So on the 17th of October, same time, 12 p.m., please join us for When Faith Meets Faith, a survivor's experience with breast cancer. And then on the 28th of October, we have a round for a cure, where the whole of Accra, we are gathering at Lincoln Community School to work in awareness of breast cancer. So please also make it a point to join us. On that same 26th, we have a lecture, just like this, a technical lecture by Ronald Panti and then Jose Pinto from Baker Hughes. They'll be talking about flexible pipe technology, a review and value proposition for the long-term energy sustainability. Please do well to join us. As well, we are on Facebook, X, or Twitter. We are on Instagram. We are on LinkedIn. We are on all the social media platforms as SP Ghana section. SP Ghana section. Follow, and you see all our updates also over there. Thank you very much, and then do have a lovely afternoon. Thank you.